Hello ROS developers, welcome to a new video on how to develop with ROS. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, ROS for autonomous cars, everything ROS is here. Learn ROS step by step and push your ROS learning with just a 10-minute video. Hi, I'm Arif and today we are going to answer this question on how to launch multiple robots in Gazebo Simulator. Before we start, remember to visit the Robot Ignite Academy, our online academy where you will find practical online ROS courses using simulated robots, no installation required. You will find the link to the academy on the video description below. Now, let's start with the question on ROS answers. How to launch multiple robots in Gazebo Simulator and how to set up navigation stacks for such a simulation. This post by Jacob, he says here there were already some questions and answers for the particular subject, like here, here and here, but this particular post is to summarize the discussion all in one place. So Jacob is not actually asking, he's actually answering. So this is his answer. Okay, and it is a very good answer. We will try to follow along, yes, and hopefully we could launch multiple robots in our Gazebo simulation. Okay, so the answer, he says here, the answer is based on the Turtlebot robot, but of course the same idea we can later generalize into any other types of robots that you wish. Okay, so before we proceed, a little bit of background. When you launch nodes in ROS, okay, we launch nodes in ROS, yes. So let's say we launch one node named Hello World. We cannot launch another node of the same name. Okay, there cannot be two nodes of exactly the same name. The first node will just be killed off. Okay, so similarly, if you launch a robot, a Turtlebot, for example, in Gazebo, and you use the same script, same launch file to launch another robot, hoping that two robots will come up in Gazebo, it won't work. The first robot will just be killed off. So you will still end up with just one robot. So how do we do this? How do we have multiple robots then? Okay, so for multiple robots, he says here, the key point is to manage the namespaces and TF prefixes. So what are these? We will see later. So in setting up the navigation stacks, each robot must operate in its own namespace as well. So it's not just about launching the robot, having them to do things like navigation or anything in that for that matter. They will have to operate in their own respective namespaces. So what are these? What is this namespace? Okay, let's imagine a particular robot will need, say, 4 nodes. The first node is called Robot State Publisher. The second node is Robot Post EKF. Third node is AMCL. Sorry. The fourth node is MoveBase. So we need these 4 nodes for a robot to work. Okay. So if we simply launch Robot State Publisher for the first robot and then another Robot State Publisher for the second robot, then they will conflict, okay, because of the same name. So what we do is we put them in this namespace. This is what we call as namespace. So the first robot, for the first robot, the Robot State Publisher for the first robot will be in the namespace called Robot1. Okay. The node of Robot Post EKF for the first robot will also be in the namespace called Robot1. Okay. Similarly, AMCL will be in Robot1 namespace. MoveBase will also be in Robot1 namespace. And for the second robot, it must have a different namespace. The name of the node is the same, still Robot State Publisher, still Robot Post EKF, but the namespace is now robot2. Okay, so effectively this and this are different now because of the namespacing. Okay, so if we have um, more nodes, for example, we have 10 nodes for each robot, then all 10 nodes must be in the same namespace for robot 1, and all 10 nodes for robot 2 must be in robot 2 namespace. And if we have more robots, then we will have also robot 3 namespace, robot 4 namespace, and so on and so forth. Okay, okay, and over here, um, it is also pointing out that let's say we have multiple robots, but we want all robots to be working in the same map. For example, we want many robots performing slam, but all contributing to one particular map, not individual maps, but just one map. So the map must not be in any namespace. It must be shared. Okay. So all right, let's do this. Okay. So as usual, we will be using the ROS Development Studio to do all this. Okay. So let's start by creating a new project. Okay, let's put a name, say multi-robot, multi_robot. Okay, description, so launching multiple robots in Gazebo. Alright, create. Okay, success. Oops, alright. Okay, there you go. And then open project. Okay, give it some time to initialize. Yeah, I'm going to say no here. Okay, so this is ROS Development Studio. This is where we will be doing our development. Okay, so let's go back here. Okay, so we are going to follow step by step as what Jacob has outlined here, but using the ROS Development Studio, and I will show you the modifications required to get it working. Because some of this, either it is for an old version, perhaps this is an answer in 2012, that's 6 years ago. So of course things have changed a bit. There will be some changes here and there, so we will go through that. Okay, so first let's make a launch file and name it onerobot.launch. Okay, so let's just copy this, copy. Before we can copy it into our RDS, we have to make our own package. Okay, so go to tools, shell, and also let's open up an IDE. So since this is a new project, there's nothing inside our CATKin workspace. It's empty. So let's first create a package. Okay, so we do that by going into CATKin first, CATKin workspace, source, and then run CATKin, create package. Give it a name, say multi-robot, dependency, ROS_PY, Gazebo ROS. You should do it. Enter. Okay, so now we have our multi-robot package. And let's create a launch folder. launch folder, because we are going to copy a lot of launch files from this page. Okay, and then let's create a new file. Let me make this full screen. Alright, and paste. So I'll press Ctrl V. Okay, so this is supposed to be one robot.launch. Alright, so save this as one robot.launch inside Captain Workspace, source, multi-robot launch. Okay, one robot.launch. So what this particular launch file will do is to launch one robot. That's it, just one. Okay, so let's go through here first. The second launch file is called robots.launch. Okay, so let's copy all this here, create a new file, paste, and okay, um, let's just save first. Save all of them first. So this is called robots.launch. Again, save it in Captain Workspace, source, multi-robot launch. Save. Okay. Next, what else do we have? Okay, the last one. This is our main simulation launch file. So copy this, paste in a new file, save it. I'm going to save it as main.launch. Okay. Okay, main.launch in our multi-robot package in folder launch. Save. Alright, we cannot launch this yet. Okay, there are a few things that we have to modify. Okay, we'll skip the navigation part for now. We just stick to just spawning multiple robots, get them out there first. Okay. Okay, so what's going on here? What's happening? We have one robot.launch which takes in two arguments. Number one is the robot name. Number two is the initial pose. Okay, and it will then spawn a robot, spawn the model um, based on the robot description that we will be providing to this particular launch file. Alright, and it will also spawn up, launch the robot state publisher node. Okay, there's nothing to change here. Let's go to robots.launch. So first of all, param name, robot description. This is the particular robot that you will want to launch. Okay, so in this case, it says it is going to find TurtleBot description, folder URDF, and this particular file. Okay, so if we want to launch a TurtleBot, yes, we will need to go into the TurtleBot description package, but in RDS, the folder and file is different. It's a little bit different. So I'm going to change this. It's not URDF folder, it's robots folder, and the name of the particular file, okay, this is a bit long. It is Kobuki underscore hexagons underscore Asus action pro. Kobuki hexagons Asus action pro .urdf.zacro. Okay, so this is the particular file that is available in RDS. This is already available. Alright. Alright, so next, So this line will only load this particular file into the parameter robot description, and one robot.launch will later on read this parameter and launch the particular robot. Okay, so alright, look at this. Let's begin with robot number 1. Let me zoom in a bit. Oops. Okay, so robot number 1, this is how we define the namespaces. We say group ns equals to robot 1. So the name of this particular namespace will be robot 1. Okay, and if you look at here, down here, when we say begin robot 2, the namespace will be robot 2. Simple as that. So this is how we say what is the TF prefix. So again, if you remember, over here it says that the key point is to manage the namespaces and the TF prefixes. So this is how we do it. Just put them in namespaces and specify the TF prefixes appropriately. Okay, so for the first robot, for robot number 1, the namespace is robot1 and the TF prefix is robot1 underscore TF. And then what you will do is you will find this file called one robot.launch, which is this one, yeah, the file that we have just created just now. So it's going to find where the package is. So it is not called your package, it is called multi robot. That is what we call our package. Okay, yeah, multi robot. So find multi-robot /launch /one robot.launch. Okay, and we are providing the initial pose here, x1, y1, z0, and the robot name will be robot1. Alright, so for robot 2, it's almost a copy of robot 1, almost a copy, just that the namespace has to be robot 2, of course. The TF prefix has to be robot2 underscore TF. The include file, this one, have to be multi-robot launch, still one robot.launch. It's the same file. Okay. The initial pose has to be different. It cannot, the two robots cannot start at the same place. They will overlap and clash. Okay, so for robot 2, x will be -1, y is 1, z is 0. So yeah, they will be offsetted by on the x-axis. Okay, robot name will be robot 2. Okay, that's it. So this is how we define the namespace and the TF prefix for the robots. Okay. Next, we go to main.launch. So what main.launch is going to do is to launch the Gazebo simulation, the Gazebo world, and then it will call up robots.launch so that it can spawn the robots. Okay, so that's what it's going to do here. First, it will start the world. Okay, node name Gazebo, package Gazebo, type Gazebo. Okay, this we have to change this a bit. The package name is actually Gazebo ROS. Okay, so change package into Gazebo ROS, and then it will find a world file. Okay, Gazebo is going to open up this world file, but in our package we don't have this world file. So I'm going to get a world file from Turtlebot, what's available in Turtlebot package. So this is just an example. Of course, you can get your own world file, or either you create one, or you can just grab from some other packages, some other projects. So I'm going to use Turtlebot Gazebo from this particular package. Turtlebot Gazebo worlds, and the world name is empty world. This is a basic empty world with just a wall. Okay. Alright, and next, start GUI, start GUI. Alright, in RDS we do not need this. Okay, so you either delete or comment it out like this. This is how we comment out this particular line. All right. Um, all right, that's it. And oh, sorry. So include our robots, include file, find not your package but multi robot. Okay, find multi robot, launch robots.launch, which is this one. Okay, so main.launch will start Gazebo and then call up robots.launch, this one. And robots.launch will first put in this param name, robot description, and it will start to spawn two, actually not to spawn, but to set up the first robot and also the second robot, and each of these will call up one robot.launch, which is this one, and this is where they will be spawned. Okay, over here. Okay, there's okay. So over here we also need to change this. This is not package Gazebo. This is package Gazebo ROS. All right. So change that from Gazebo to Gazebo underscore ROS. I think we are ready to go. So save this file. If you see this circle here, it means that the file has not been saved. Now that I've saved it, it turns green and then it just goes away. Okay, so this is saved. This is saved. Alright, main.launch. Save this. Okay, so let's launch our files. Let's go to, let me minimize this bit. Let's go back to the shell. Let's do ROS launch. The name of our package is multi-robot. And we are going to launch main.launch. Enter, go. Right, and to see the actual simulation, we have to open up Gazebo. Okay, give it some time for it to load. Waiting for WebSocket. Okay, it's loading. Almost there. Alright, it's done. So that's one robot. And let's zoom out. Yeah, that's another robot. So we have two turtle bots here now. You see that? Two robots. Okay, in the same Gazebo world. Alright, and this is just a wall. Okay, so now we have successfully spawned two turtle bots in the same Gazebo simulation. Alright, now you might be wondering, okay, so we have two robots now, but how do we control them? How do we move them? Okay, let's see how to do this. Let's open up another shell. Okay, I'm going to show the simplest way of controlling the robot, which is through the topic command bell. Okay, we are going to control the robot using keyboard teleop. You can also try and go back to this ROS answer post um, and try to set up this navigation part. This is more interesting. You will be able to control the robot with using RVs. You can give a goal and you just go to the goal position, waypoint, so on. But I'm going to show a different way to do it, a simpler way to do it. Alright, so we have a new shell. Let's first go ROS topic list. Let's list out what are the topics that is available. So let's see. So as you can see, there are many topics which starts with robot 1. So anything that starts with robot 1 are in the same namespace. robot1 namespace. Okay, and you can see that there is this robot1 slash command val. Command val is the particular topic that we will be using to control our robot, to get it to move forward, turn right, left, so on. Okay, and there is also robot2 topics in robot2 namespaces, and you can also see that there is another command val, but this time it's robot2 command val. Okay, so this is for robot2 and this is for robot1. So it depends on which robot we want to control. We have to publish to that particular topic. Okay, so let's do that. Okay, so let's say I want to okay, so I want to use keyboard tally op. So let's ROS run tally op twist keyboard tally op twist keyboard.py. Okay, this node tally op twist keyboard will enable us to publish in command val topic. But what we want is we want robot1 command val, not just command val, but robot1 command val or robot2 command val. So we have to remap the topic. And how do we do that? It's not that hard. Just make this so that you can see what I'm typing. So we just call that ROS run teleop twist keyboard.py, and then cmd val remap into, oh, I forgot the slash command val remap into robot1 slash command val. Okay, so this is for robot1. Let's try that. Press enter. Alright, so it is loaded. Yes. Oops. Okay. Alright, so in order to use a keyboard tally op, we have to make this particular window to be active window. Okay, so how do we move this around? We can use I to go forward, K to stop, what's this, comma to go backwards, L to turn right, J to left. Okay, so you get the idea. So let me just try this. I'm pressing I, and there you go. So you see the robot move. This is robot number 1. So let's make it turn now. I'm pressing L, and then let's go forward again. Okay, let's turn left, go stop, reverse. There you go. So that is for robot number 1. So for robot number 2, we have to do the same thing. I've just stopped this node. So we are going to do to run teleop twist keyboard by, but this time it will be remap command val. We are going to remap it to robot2 slash command val. It was robot1 just now. Now it's robot2. Okay, so run that, and now I'm pressing I. Yay, now I'm controlling the second robot, not the first one anymore, but the second one. Alright, there you go. So now we have 2 robots in Gazebo, and we can separately control them. Of course, if you make a script to control them, you will have to publish to the appropriate topics, as we have seen here just now. Okay, one last thing before we go. Let's try and spawn another robot. Alright, so let's go back here into our editor, IDE. Okay, so the idea is again here. This is where we spawn the robots. This is where we define what are the robots, and how the name of the robot, the position of the robot. So to make another robot, to spawn another robot, it is simply copy this, paste here, and let's change some things like begin robot number 3. So group namespace now has to be robot3. TF prefix has to be now robot3 underscore TF. The same file is, did it say one robot.launch initial post? We have to change the initial post. They cannot be on the same spot. So robot1 is at 1, 1, 0. Robot2 is minus 1, 1, 0. Robot3, let's make it minus 1, minus 1, 0. Okay, and the name will be robot3. Okay, so save this, and okay, let's press Ctrl C here, kill this off, kill off the current Gazebo simulation. Okay, let's give it some time. It's still running here. If you can see, it says it is still running. It's turning off, but let's give it some time so that we are sure that it is turned off. So sometimes we have killed process here on the shell, but in the background something is still running, especially Gazebo server still running, so seems like it's not going to stop. There, stop now. Okay, proceed again here. So just launch again. Okay, same command, ROS launch multi-robot main.launch, enter. Okay, let's wait for it. Okay, waiting for WebSocket. It says simulation running now, but it's actually still loading. This is not the actual simulation. What we are seeing here is not the actual simulation yet. Still waiting for the WebSocket. Still loading. Let's give it some time. It's taking some time. It's probably due to my internet connection. Slow internet. Still waiting. Come on, Gazebo. Let's go, let's go. This is taking some time. It's okay, we have time, don't we? Still not loading, still. No, not this one, still waiting for WebSocket. Why is it not loading? Did I save this? I did, yeah. Robots.launch, this is saved. Everything is saved. Okay. Let's go back here. Let's go back here. Let's try and relaunch this. Not sure why. It should be. It's taking quite some time. Let's try and relaunch. It's still running. Let's give it some time to actually stop the simulation. Okay, it says simulation stop running now. Okay, so let's do this again. ROS launch multi-robot main.launch. Go. Let's go. Oh, yeah, you can even see here. Scroll up a bit so you can see there are in the list of nodes. There's robot 2, robot 3, and robot 1. Alright, so we are expecting 3 robots here. Where are they? It's coming up, but not yet. Let's give it some more time. Okay. We are still waiting. What's going on here? Aha. Alright. Okay. Give it some more time to load. I'm so excited. I'm getting so excited already. Connected to the simulator. Loading. 99% loaded and go. So that's one. And number two and number three. So we have three turtle bots in the same gazebo simulation. Alright. So three robots, one simulation, one simulated world. And again, to control the robots, you know it already, we have to publish command val to the respective namespace. It is not just command val, it's now robot 1 command val or robot 2 command val or robot 3 command val. Okay, so there you go. That is how you launch multiple robots in Gazebo using ROS Development Studio. Until next time, have a good one.